Learn to safely modify shared numbers across threads using atomics. Let's look at an example that demonstrates how you can use atomics for addition and subtraction for a safe thread, memory allocation or buffer in JavaScript. So let's move on. And the first thing I want to talk about is the fact that when you have a multi-threaded application and you want to do things that increment or decrement a value, it is usually dangerous because it takes 3 steps. Basically, if you have something like this in a multi-threaded application, count plus plus, or this is one, or you have something like this that says count plus equals plus equals. Now, this type of process is dangerous because it takes 3 things. Number one is that it will first read it. After that, it will add, and after that, it will now write. So, in between these 3 steps, if care is not taken, a background worker can sneak in between these steps, and then it can lead to corruption of your, whatever it is that you are doing, whether calculation or any other thing. So, in order to avoid this or deal with this, that is what atomics help us do. So, atomics add method combines the reading, the addition, the calculating, and the writing into one single unbreakable actions, while handling your original number as a helpful receipt, which means that even if a background worker try to sneak in, it will not be impossible because the action will be in a one unbreakable action. And that is exactly what we want to look at in this example. So we want to look at how you can rely on atomics to help solve issues like this in the multi-threaded application. So I will add a comment. The first thing I want to set off is a shared 16-byte buffer. And this, we want to divide it into 4 slots. And each slot will carry 4 bytes each. So how do we do that? Well, I'll go ahead and just make a variable, call it buffer, and call on the new shared array buffer method. But instead of passing 16, so I'm going to pass 4 and in 32 array constructor to get how many bytes per element that we have in our shared buffer. So now that I have this, then I can make another variable and call this shared array, and then I'll call on the new int32 constructor again and pass it my variable of buffer. So now that I've done this, it's time for me to initialize the starting value. And how do you do that? Well, just call your variable in shared array, use brackets notation to pass it a value. And in my case, I want to assign the starting value of 5. So now that I've done this, it's now time for me to do thread addition. Thread addition. And for this thread save addition, so let's say I have a variable and name it old value. Then I can call on this atomics and say atomics.add. This is the method. And then call on my variable shared array. Give it an index position where I want a value to be added and give it a value to be added. Which means that this is going to add, add 3 in the index position of 0. So now that I have done this, I can just go ahead and display results and say, okay, console.log plus code value, and say, okay, console.log again, new value, and shared arrays, another value of what is it called? In my old value, do not forget that I have an initial starting value of 5. So what I'm doing inside this display is that I'm trying to console log this old value, and this old value here is going to be 5, which is the starting value. Why the new value, which is this shared array 0, is going to pick what I have already, which is that starting point of 5, and then add it with 3. And this will give me an output of 8. Now, you might not see anything inside my console, right? Because of hardware exploitation, my browser is automatically blocking this shared array buffer. Let me even see the problem for wow. Of course, I don't have expression without this. I really don't have any issue in my that chat as it is. But nevertheless, this is still not showing anything, and it is not going to show me anything on the screen actually because of that hardware exploitation. So you can see shared array buffer is not defined, and that is because if you check my window.cross origin isolated, this will return false. So unless it is set to true, then it's actually not going to show me this output on the screen. But for this exercise purpose, I'm not going to go through the process of configuring my editor to support my browser to display the value, but I'm just citing an instance of how that can be done. So if your own browser supports it and does not block it, then you actually see results. Or better still, you can just check out this information online, that how can you set your cross origin isolated to true, and then it will give you a couple of workaround that you can use in order to see the result in your console or on your screen. So now we've been able to see how we can use atomics to add and either add or subtract while simultaneously capturing the value before the math operation took place. So the essence of this example is that it shows us how to add number to an index slot. You can see how we add to an index slot of 0. And that index at position 0, not 0. This index position of 0 is already holding 5, which is our starting value. So it shows us how to add these 3 to an index slot holding 5 in a thread-safe way, proving that the method returned the original value, which is what we have here, rather than the new sum of 8.